Chapter 3.3.
Oh, we're going. Wait, is that it?
Yeah.
We're not doing any problems on it?
We'll do some more problems after dinner.
Napoleon triangle.
Well, we're not really going to talk about Napoleon triangles, but that's what the chapter's called. So the Napoleon triangle part's at the end.
Okay. Don't put that in mind.
Okay, so we should now examine some figures built with triangles and, well, yes, quadrangles, but that's defined earlier. An easy theorem that has been surprisingly neglected is the following. Okay, that has nothing to do with quadrangles at the moment, so that's fine. Sort of.
Wait, is it? Did Napoleon invent?
Probably. Napoleon invented.
Oh, okay, well, if you care about why it's called Napoleon, it was like, it is known that Napoleon Bonaparte was a bit of a mathematician with a great interest in geometry, whatever that means.
Oh, you mean the conqueror Napoleon?
Yeah. In fact, there is a story that before he made himself ruler of France, he engaged in a discussion with the great mathematicians Lagrange and Laplace.
Oh.
You've heard of these guys, right?
Lagrange.
It's like
Yeah, because we used
until the latter, I guess that's Laplace, right? Told him severely, the last thing we want from you, General, is a lesson in geometry. Alright, and then Laplace became his chief military engineer, whatever that means.
Oh, basically he's designing all the weapons because he's good at math.
So theorem 3.36 has been attributed to Napoleon, though the possibility of his knowing enough geometry for this feat is as questionable as the possibility of his knowing enough English to compose the famous palindrome, Able was I ear, I saw Elba. What's Elba?
Elba's the island
This
where he
is
got
classified as good
exiled.
for us.
He got exiled to Elba, he came back and he kicked his ass and then they kicked his ass.
So at any rate, it is convenient to name the triangle blah blah in Napoleon, the Outer Napoleon triangle or something. So that's later on, but right now the theorem we care about, theorem 3.31. Okay.
It's really cold in here.
3.31.
It's very typical.
Okay. So you have a triangle, yeah?
Yeah, we have a triangle show.
There's an epic triangle.
Okay. And then you make three triangles outside the triangles. So like this, yeah? Have you seen this?
The lines that are straight, right?
Are they equilateral?
No. So the all you need is you need the outer angles add up to 180. Yeah?
It is random triangles, right? Where outer angles add up to 180.
Oh.
Yeah, so you need PRQ.
Oh yeah, and then it's opposite things are
Do you know this?
concurrent.
What?
It should be. You prove it. Don't you prove it with Chaver or something? Sine Chaver, two Chaver.
So this is P, Q, R. Yeah.
Just plain angle Chaver.
Yeah. So PQR add up to 180, yeah?
PQR.
Well, that's
So are they straight lines?
No.
No. But that's a good question.
You just add them to 180, that's all.
No, I mean like PAQ, like the big lines. Is that a triangle? Is there a big triangle?
No.
Well, that's a good question. So it could be. But anyway, yeah, so that's a good question, but sometimes we have to find the right place for this. I'll explain why your question is good in a second, okay? So it's a good question at the wrong time, slightly.
Because the diagram is
It'll be a
pretty
great
unclear.
question at the right time. No, don't change this to something about the diagram.
Gee, why did you jump to the middle of the book now?
Oh, because that's number theory and that's geometry.
So the conclusion of this, it's obviously not a
And
theorem
there's
yet. There exists diagram. No.
And what's
The theorem is
Oh no, don't see
the
that.
theorem is
That's
the
Did you draw something
circumcircles of the three outside triangles are concurrent.
Circumcision. Oh, okay.
Yeah.
Oh,
naughty.
right,
I think no.
Does that make sense?
Naughty.
So if we draw the circumcircles for these three triangles, right? They all intersect at one point.
Oh, well, that makes so much sense. I think. I'm pretty sure. Because, like, if you take opposite angles, they're up to 180, right?
Ah, yeah, so we can, that's how you would prove it, yeah.
Wait,
But how
what's
do you know
the
the
what?
concurrent? You didn't.
Wait, it's not concurrent.
It is.
Is that what you said?
APBQCR. concurrent.
3 circles, yeah? What are you saying? So I'm saying if you have 3 circles, like
Oh, three. Okay, wrong theorem.
Never mind. You remember too many theorems.
Oh, I left my compass outside. Bad luck.
Okay, sure. The hands are like
Fine. Oh, holy crap. No, it's not going to change one.
I probably should use another color.
Pell's equations.
I'm going to use another color for the last circle. I don't even need to draw the whole circle.
What are you doing?
What are you doing? Can you stop being so annoying?
What? Why am I being annoying? I'm just talking.
You keep on touching my body parts.
What? What? We're packed very densely here. It's just an X.
Yeah, but that doesn't require you touching me.
It's just random.
So the radicals then.
Radical center.
It's don't spam, okay?
The radical axis.
Come on, focus.
The radical
Magical axis.
Somehow contains somewhere.
No, they will.
Wait, can you? Apparently, you can put my
Find
down
the
on
radical axis of the circle of the source.
Okay, so let F be the intersection.
AFC plus APC is equal to 180.
Napoleon.
This is not Napoleon.
It's not even a
No, I read the other one out of order.
Like, this is not Napoleon film.
No, it's Napoleon triangles section, but we don't really get up to that.
Isn't it the same thing then?
It's called 3.31 in geometry.
Okay.
3 points.
3.31.
But it has been surprisingly neglected, and it's easy. That's what it says. But of course, surprisingly neglected in like 1970s or something. And now it's probably over on non-neglect, like over.
Overemphasized.
Yeah.
That's the word.
Okay,
I hate
This is the 1970s.
Will you
guess
please
maths
do
hasn't
this?
changed.
Sure.
be proactive.
Sure. So
Stop waiting for me to tell you the answer, and then you
So what are we-
passively.
So what are we trying to
ignoring
do?
me.
What are we trying to do with these triangles?
The conclusion of the theorem, yes,
Yeah.
is basically that F. So basically, because every circle, right, it lies on A and B, and then there's an outside point over there, right?
Yeah.
Okay. And this circle does every circle does that, the same thing, right? And we're just saying that the third point is also on the same. They also intersect. There's a third point of intersection.
That's all. You just add AFB.
Wait, hang on, I'm solving.
Okay, buddy.
Let's draw another tissue diagram.
Yeah. So basically, you want to show that this F lies on this circle, yeah.
Yeah.
This F.
Is this pure angle trace?
Well, problem solving is kind of, you need to actually make a read,
Yeah,
yeah.
I can. Wait, I can do it. Yeah.
Wait, isn't it like some? Is it something to do with like the radical center?
Oh,
'Cause that's
No,
what
no,
we learned in chapter 2.
No, we claimed it was an easy theorem, okay?
Yeah, you radical center. You just need a geometry.
Which I didn't learn because I was away.
Geometry.
Don't be small.
You're so smart, G.
Don't be small.
You're so smart, G.
Well, if you look at the triangle, the triangle can have any 3 angles, but it's
Crap, I misdrew the diagram.
Wait, is my old question now relevant?
No.
No, because you haven't even proven it. Well, you haven't proven it, and I'm trying.
So where would the radical center be?
Oh, we proved
Obviously, right.
Yeah. So I guess it would be the radical center.
Yeah.
Yeah,
Because the 3 radical centers,
they
they're definitely not coaxial, right? Can we prove that it's trivial that it's not? They're not coaxial.
Yeah.
Yeah, the problem is, like concluding that that's the radical center doesn't mean that they're gonna actually meet there too, right?
Because just a radical axis is
Like,
not the same.
Because it's the it's where two AB and BC are both radical axis.
Alright, so we're good.
Yeah.
Yeah, so some angle chasing, yeah?
You could just say, no, it's not really. You have to do an argument at the end.
Sure, yeah.
You can't just assume that the circle lies on it.
Oh no, just.
No, but like, the last angle will be, right?
Oh, so you're saying,
I think I know how it works. You make.
I made stuff more complicated than shit.
I think I know how to prove this. I got this. You don't prove first that you want to set the 1 point.
See how ticklish this is.
So you just have to show this is a cyclic quad, yeah?
It's very
I felt it
ticklish.
and it feels good.
You know you don't have to. Well, yeah, sure. So, yeah.
Please don't touch body.
That's obviously cyclic. Therefore, opposite angle.
That's so funny. I'm assuming.
Yeah. So can you see the angles at F, right?
Yeah.
This is 180 minus Q, yeah?
And then the other one,
This
180
is,
minus.
this is 180 minus R, yeah? P.
Minus P, right? So the other angle, the
140 minus 180.
It's P plus Q, yeah?
It's like Napoleon was just milking formulas.
Yeah?
It's like he was just
He
milking
kill 100
formulas.
Okay, so the people who... So...
Wait, where did you define P and Q?
What?
What?
At the very
What?
start. It's just...
Oh, okay.
You are at 180.
I drew on a stone.
External angles.
Okay, so now seeing comments of interest, okay? Oh, by the way, those who claim that they know the pivot theorem have still not recognized that this is the pivot.
I know. Yeah, I didn't mention.
I don't know the pivot.
I know.
Well, if it was,
I
if it
didn't
was,
mention it. I know. It's any point inside a triangle. You can make. Is
That literally handwriting? No, okay.
if it was collinear, that was the word.
What? No.
Yeah.
No,
If RAQQPC, so
Yeah,
no,
so
but
it's
I
a special
wouldn't.
case of this.
I don't recognize it because it's not straight line, so I don't need to.
I can't do
If you
it.
involve straight lines,
I
I
can't do
Yeah,
that.
so what I'm saying is, like, when we learn something, right, like, it's not just, like, know that check the proof works. It's like we need to understand it and be able to recognize it when it comes up. So can you see, so the Miquel, it's like called Miquel, the Miquel theorem or whatever, right? So if you have a triangle,
I take it as yes.
Yeah.
so if you have a triangle, yeah?
Yeah, when I hold that up, it means.
So if you have a triangle, yeah? If you have a triangle,
Triangular.
and you have a circle that passes through one of the vertices like this, yeah? Yeah?
Yeah.
And then you take this point of intersection, yeah? And then this here, and have any circle that passes through those 2 points, yeah? Yeah? That makes sense? Okay. Then you do the same thing with this circle, right?
And therefore, it's like.
And this one, and this one. The point is that this 4 points lie on a circle. That makes sense?
It's always possible somehow.
Yeah. Can you see that?
I
I
don't
know that.
recognize.
So this is cyclic.
I just did it.
Why do you say?
Wait, did we prove this before?
In some sense.
We just make we
Well,
define
like,
a point
it's a special case
and we
of this,
define it.
So- Is,
False
this
answer.
is your question, right? Is RAQ a straight line? Yeah? If RAQ is a straight line, then that's this case.
Yes.
Okay, I'm missing the oh. Okay, anyway. So RAQ,
They have to be collinear.
RAQ, yeah?
Yeah.
And I'm still missing the R. Okay, then there's a P is here, yeah?
Isn't it just flipped around? Like,
Yeah, so this is
It's
that
just
flipped around. Because if it's all collinear, that's a triangle, right?
Yeah,
You have
then
a
that would be
circle,
definite. That would be
circle,
definite. Oh,
Circle,
okay.
yeah?
But isn't that the
The pivot
converse?
theorem is.
Huh?
Isn't that the converse?
No.
Yeah, sort of. So, like, this one you drew the circles first, right?
Yeah, you don't know if they're
That
like.
one you
But that one
You
we
drew a
didn't draw it. So pretend we didn't draw R, right? Yeah? We have the F, yeah?
Yeah.
So we're just saying F, A,
And
any
then
point R,
point,
and make sure the angles add up, yeah? So that would be the R on the triangle, yeah?
Yeah.
So that's any point R that the angles add up, yeah?
Ah.
Yeah? And then the B and the A are already there.
Because you don't have to draw R until you have to.
Yeah.
Oh.
Okay.
So you might want to separately angle chase this. Do you want to separately angle chase this?
540.
Yeah, okay, we'll just do the bottom
So 6,
Because
basically.
like, Because like you're proving the converse, but in geometry the converse is pretty much the same. As
Yeah, so look, this is P, right?
Not especially.
This is like Q, yeah?
Yeah.
Right?
And then join.
So this angle here
Oh, okay.
is 180 minus Q, yeah? This
I went
angle
through the same
here,
question.
180 minus P, because some people are skeptical.
That one's P plus Q.
Why? It's just like the
Yeah, so this is P plus Q, right?
Isn't this the same thing?
This point
Oh,
will
now
always
it's
exist.
a
For
special
people who
version of this.
realize, yeah.
What if like this triangle's obtuse?
Huh?
What if this triangle's obtuse?
Then you're obtuse.
So this is actually a kind of an obvious generalization of this as well, right?
Whoa.
Fuck you.
Yeah,
Alright, stop swearing.
Because you're just using the property of triangles that they have.
You're
Guys,
Can I
stop
go
pretending to be
Getting
tough.
poked in 3.
Wait till you're adults and I'll just beat you up.
Wait, who?
What? Who?
No, I'm just kidding.
Who will
Alright.
beat you up?
I actually paid
Me.
myself onto you.
Oh, okay.
Wait, actually, is beating up children worse than beating up adults? Like in the view of the law?
Depends on what
in
type
the
of
view of
children
the
they are.
law.
Okay, if you beat up a 1-year-old, then obviously they don't know.
We have a problem.
But what if the 1-year-old is
Yeah.
actually evil?
Okay, hold on a second.
Like you.
What happened, guys?
What?
You started drawing. I claim that you have started drawing these diagrams in your one.
Why did he draw it on your page?
I do not know. I'm sorry.
Oh.
I do not know because I'm still upset.
What the?
Why?
Okay, there's some pretty
Like,
crazy
Bible.
claims. Yeah, so listen up. This is some stuff we have to understand now. Okay. So theorem 3.32 has been named by Forder the Pivot Theorem. It was discovered by A. Miquel in 1838. Changing the notation, blah blah blah.
But that's so recent.
1838.
Yeah.
No,
It's
it's
so
not.
recent. That's actually
The
quite
pivot theorem, that's so recent. Wait,
Because something that's that
the
obvious.
Napoleon triangle, Napoleon was before 1838. So he just
Yeah.
proved a direct sub case of that, and then he.
No, this is not Napoleon's theory. We established this too many times.
No, Napoleon's triangle is in the chapter. Napoleon is relevant for the rest of the chapter.
That's
Yeah.
so recent. It's just.
Yeah, for something that's so obvious, that's quite
Yeah.
recent. Like, look at the proof to
What do you
1
mean
plus
so
1 is equal.
obvious?
Alright, so there's some interesting insights here that we should try to spell out, okay? So that's theorem 3.3. Okay.
Copies. Your copies.
Alright, what's theorem 3.33? Okay, it says PCB CQA. So this is meant to be a special case as well. PCB CQA BAR similar.
Okay.
What?
So if
Yeah.
Oh,
you
if.
have these three similar, yeah? Erected externally on the sides of ABC. So it's the same situation, yeah?
Oh, then the things are concurrent.
What's
The lines are concurrent.
Then the circumcircles of these three triangles have a common point.
Wait, is that? Wait, what?
It's the exact same thing, though.
I mean,
It's
the
just
line's
like,
concurrent is like, it's like this one, right?
No, I meant AP.
Oh, that's collinear.
APCR and BQ concurrent.
Yeah, so basically this one, like if you didn't have the R, right? It's kind of like saying if you drew this P anywhere here, right?
P anywhere.
Yeah, and in such a way that
Swats.
Could you
That's your.
Please stop saying it's not funny. Sexual assault because
You did that.
That's just a direct consequence of that again. You can have some full text.
yeah, like you could find R to be yeah. Anyway, so let's go back to this. So, PCB, CQA, BAR similar on the externally on ABC like that, right?
Yeah.
Then the three circles.
Then the circumcircles have a common point.
That's just the
Wait,
same
isn't
thing
that the same
over
thing?
and over and over and over.
Wait, so why do we?
You're just not appreciating the difference. What?
Wait, why do we need the like similarities?
Oh, so it can be. Oh, but like if similar, it can be different directions.
obviously you
Like then it's not collinear.
Wait. So the only condition we had before was that the angles added up to 180, right?
Wait, is this?
So the similar is supposed to replace that condition.
Oh,
yes?
Exactly.
There's no. Out 180 in this one.
Yeah, there
Yeah, I mean,
is.
no, there isn't because
Yeah,
if
but
there
it
was,
is by similar triangles.
yeah, I mean if they're similar, right? Then they would add up to 180, I suppose.
That's why
Which
you
angles?
get that same condition.
Wait, which angles?
Okay, so you see how angle P is the first angle, angle Q is the second angle, and angle R is the third angle?
Yeah.
Yeah. So therefore P plus Q plus R is 180.
Why would they have to be?
It's the same thing.
Do they have to be? They don't have to be
Why
in
can't
that
they-
order.
No, it is in that order.
Why can't it be? Wait.
I think it is.
Wait, no,
I think it
Wait,
is
no,
in
no,
that
no. If
order,
you look
right?
at it, right? PCB and oh wait.
Yeah.
Oh yeah, it is. Yeah.
Mm-hmm.
So you're saying
Is it? If
What's
it's not in that
they-
order, then it's probably not true. It's probably in that order.
what order is it in? So
Wait.
PCB corresponds.
Yeah.
So it's P corresponds to C. Is that what you're saying?
Yeah.
So you're saying
Corresponds
this, yeah? P, C,
Yeah.
and then B, yeah?
B.
Yeah.
Yeah, and then all those three angles are different basically.
But it might not be.
But it's in that.
Well, that's just in the lettering. They can
But-
make mistakes.
C, Q.
What?
Dot. Open circle, open circle, open circle. Beta, 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 and gamma,
We
gamma,
should
gamma.
lock you up in a
So like
conversation.
alpha comes to beta,
See how much you
gamma
like
comes
sauce
to
because
increase. So you have one alpha and one beta and one gamma at the corner.
Yes.
And then that happens, or you have all three lines to concur.
I like smelling Hitler's cats.
I mean, PQ are all different positions. So.
Well, he's gonna fast through the.
Oh, it says actually makes a comment. Note from the order in which we name the vertices of the similar triangles
Yeah.
that the angles at P, Q, and R are not corresponding angles.
Oh, okay.
What?
Sure, alright then.
What?
I guess.
They are corresponding.
No. The corresponding ones would have to be equal then.
Yeah,
right?
this corresponding would be like 2P. They would add up to like 2P or 3Q.
No, yeah, that's what I meant. They're not corresponding.
They're
So it's
corresponding.
PQR.
Yeah.
PQR is 180. That's what I meant.
That's what they said.
But they're not corresponding. How do we know they're actually all different? Or is that what they mean?
Yeah, they mean
that
that they're similar in the order they write. So like, because P, Q, and R are all like prepositions.
Oh,
I
yeah.
guess,
Okay. Yeah. I mean, like, guys, so it's meant to be called the Pivot Theorem, right?
Yeah.
And we have no understanding of that particular aspect of this theorem, yeah? Where is the pivot?
The F point, I guess.
Well, it's not the F point. We're trying to prove the pivot is at the F point.
Yeah, and so so if that's you're pivoting about F, like, F is also there, right? It's P, I guess. Like, what does it mean? Like, so it's the point, and then we're gonna pivot involves some kind of moving, right?
Yeah, but in geometry things don't move.
Okay, thank you.
Zane, you're smart.
You're out of the class.
Who's our who's class?
So your roles just reverse.
What?
All right.
Yeah. Roles reversed.
Why is
my
Stone
role?
Pencil
Why is my
suddenly
role
become a
reversed?
thing?
Can you explain?
Why has Stone Pencil suddenly become a thing? Lol.
It's like the roles of people asking questions and making statements have just reversed. Alright.
Did Zing just answer the question?
Why don't you let Zing become the teacher for?
It's almost as crazy as letting David become the teacher.
What
Almost.
do you mean?
Almost.
Who's
I'm
crazy?
so screwed.
I can teach little kids like you how to do math.
Why is the
Are you sure
Okay, guys. Zing, do you know what 1 plus 1
I'll
is?
just leave the issue.
What is it?
You have to write 300 page proof.
No, the answer is 2. And deal with it. You little shit.
What?
Okay, so there's something maybe for a little bit more. It's not completely finished.
I don't know. You still have to survive.
Ah, so they're looking for diagram 1.9a.
Oops.
What this?
Can you hold this page for a second?
Yeah, what this?
It's fine. Okay. Now it's not fine. Now it's not fine.
Well, it's just sign. Sign.
Okay, so it says to recall this triangle.
So this is a pivot.
A, B, C.
Koreans are so smart.
A1, B1, C1.
So the P's are pivot, right?
What's this? Recall what diagram?
This is pedal, yeah?
Pedal. Oh, okay.
The pivot for our triangle.
6960.
No.
The circumstance of what we call a pillar.
Alright, shut up. Okay.
Wait, is it own code?
Wait, why are the two A1s?
What do you mean? Oh, like the.
Okay, so if ABC is a triangle,
I got the ABC.
So
Huh?
two A1s.
Yeah.
2 hours.
That's
Two
like
What?
A1s.
The one that ABC one.
oh, why are you so happy?
He's been complete.
We can't be happy till we understand this.
Oh yes, can we play Kahoot?
Yeah. Why?
Just because when I don't,
Jeez.
I'm
Let's
not.
do a Kahoot on geography.
See, like being smart is not a permanent state, actually.
Oh really?
Yeah.
Yeah, because at the moment, after like all this extra exercise and stuff, you're all very dumb.
Well, we weren't dumb in the first place.
Let's do it.
Yeah, but now I can say you have an excuse, and I won't be attacking you personally, I guess.
Yay.
All right, so if ABC is a triangle, yeah,
Yeah.
and A1, B1, and C1 are any 3 points on the lines BC, CA, and AB, yeah.
Yeah, then A1, B1, C1 are concurrent.
No. That's like
So then,
5 months ago.
then the 3 circles A, B, B1. So A, where is this? A, B1, C1, yeah. B1, C1, yeah.
Why are you using my pencil?
If they intersect in the middle.
It's funny why I'm using my
So
pencil.
A, B, 1, C, 1. So angle A, angle B, and this. Yeah, they do. So yeah, they do.
Why are they really small circles?
What are we doing now? So like ACB intersects what?
We're trying
The
to
center.
prove that.
Uh-huh. So we got ABC, right?
Yeah.
Any 3 points, A1, B1, and C1, yeah?
Okay.
And the perpendiculars they meet. The missing. Intersecting perpendiculars.
We haven't assumed they're perpendiculars yet.
They're not.
Not yet. We haven't drawn the middle point in yet. Okay.
Collinearity and concurrence.
So A1, B, C1, yeah? So A1, B, C1,
Okay.
yeah? Yeah. And then the last one is A1, B1, C, right? A1, B1, C.
And what? Did they circles?
Have a common point, yeah?
Yeah, but it's like we're.
You mean they're circles?
Hmm?
You mean they're circles?
Yeah, if you draw
Wait,
the
so why did you draw the 3 lines in the middle?
Yeah, so
Are you-
it's gonna relate to the pedal triangle, okay?
Isn't this the pivot theorem again? It's
Yeah.
the pivot theorem again.
We're
Yeah.
trying to use it with the pedal.
With a pedal triangle.
Oh,
Oh,
it's like you
This
guys.
is pedal triangle. What do you
It's
have
so
against that?
immature.
This is
Shut
like
the
we're at like
F up.
some like mental clinic, and it's hard to string anything coherent together because at any like step, some retarded person screws up. Yeah.
I said pedal triangle. What are you talking
Why
about?
is typing never screw up? There's a pattern here. I see a pattern.
Yeah. No
Yeah.
offense to the mental clinic people. Yeah. I'm really just talking to you guys.
Circumstance of the middle triangle is right.
Huh?
Circumstance of the middle.
Okay. So they meted a point. Okay.
Why do you like
I think this is
everything
for him. If you
genocidal
remove him out of the
and
equation, everybody will be
upright?
much better.
What?
Why do you like
Why-
everything
Yeah,
genocide?
that's
and
why-
Cradle?
Okay. They meet a common point P. In the special case when the circles AP, BP, CP are diameters, have AP, BP, and CP for diameters. Yeah.
Okay.
So AP is a diameter, so that's the pedal triangle. Yes.
What?
Okay.
AP?
Wait,
That's a special case.
are we?
Yeah.
Oh, it's a special case
Then
again.
Yeah.
P is the F.
So it's even more of a special case of a pivot
Yeah,
theorem,
but
which
the
is
goal
already
is not to generalize everything, right?
It's not.
No, because when something happens in general, there's just one reason that works for all those things, yeah?
Yeah.
But when something is special, there could be lots of different reasons that make that special case very interesting, right? So there's like a special to general move that you have to learn how to do, okay? Yes? Yeah, and so the thing is, how do you solve problems? How do you do maths? You basically find transformations that preserve stuff, right? If you solve a problem, you're basically finding ways of manipulating the problem that still preserve the solution or the idea, right? Because that's what trying special cases is interesting, because it kind of preserves the idea, but you're going into a simple situation, right? And you can do everything explicitly. Generalizing also works because you preserve the problem, but you take it to a setting where only like this one idea can work for everything, right?
It's like when you specialize, there's a lot of ideas. So when you
Yeah.
special to general, basically means you're trying to weed out the ideas that are not that relevant for the problem, and find the idea that works to solve the problem.
I still feel sorry for all these mental people I've offended by using them to compare to
They
you.
wouldn't know they got offended.
That's
I
like
think that's your first mess up of the day.
that's off topic.
That's your
Alright.
first mess up of the day. I mean.
Okay, so in this special case,
Wait, when did I mess up?
P-
mess up by saying like,
so
I
the
don't remember,
P
but, like,
I
is
never said anything.
the pedal point and the point of intersection, right?
what
Okay.
is the wait?
Because
Wait,
the
can you
diameter is
reiterate the
That's the
importance
diameter.
of the
Yeah,
pedal
yeah,
point?
The
yeah.
line of the circle, right?
Is that just where the
So,
three
so
times?
if you just pick the point anywhere, right?
Yeah.
The pedal point is where you have like altitudes. So
Oh, okay.
you
sure.
make these altitudes from P.
I
Yeah?
got that.
Right. So since it works for any 3 points, A1, B1,
Yeah,
B1.
you can always get a point that can straight.
Yeah, and you can always move P anywhere, right?
Yeah.
Okay.
Yeah.
Okay. Alright, so we're kind of on the same page here. So keeping A, B, C, and P fixed, right?
A, B, C, P, 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 P.
We can rigidly rotate the three lines PA1.
Okay.
I have a red pen for this.
Rigidly rotate.
Rigidly rotate.
Go on.
So keeping P and the triangle fixed, we can rigidly rotate the three lines PA1, PB1, and PC1.
Oh, and is it saying that
They
P
still-
is still going to be
PA1,
that's weird.
PB1, and
But their angles are
PA1.
different. Surely their angles are different.
Oh, wait.
See if he is still.
Oh,
So what does rigidly rotate mean? I
it means
guess.
changing without changing the angles like between each line. So you're just rotating all three lines.
Wait. So you're saying, wait, isn't it don't change the length?
This one else one.
No, the length changes.
Length-
The
The
angles
length
don't
change,
change.
but angles don't change.
Oh, you're just keeping them like that, yeah?
Yeah.
So the length will change.
But how do you know the angles within each one is the same when you rotate?
Rigidly rotate, that's what it means.
No, I mean like, what the B1s, C1, and A1 be different?
Yes.
Oh, okay, good.
So you're saying basically like alpha, beta, gamma, yeah?
Yeah.
It's still alpha, beta, gamma. Yeah?
No, but it's been rotated.
Yeah,
so-
so the set out one.
Yeah.
It's still be feels so weird thing.
Until you get past that point.
Until
Until you get like.
Oh, yeah.
it crosses.
until you
Crosses
cross
what?
B or something.
What?
Yeah.
Until like the
You get a very
the
fat
line
so
crosses the other end, the vertices.
like C1
Yeah.
crosses B or something.
Okay, so if you rigidly rotate them about the pivot P,
Wow.
Epic.
difficult, not easily impressed, this person.
Who?
Through any.
Are you talking about?
Thank you for maintaining the role of the questioner. Okay, so the pivot P through any angle. Through any angle.
Whoa.
Does that mean you can actually go past?
Oh wait, hang on. That's weird though.
So that's weird. Let's slow down.
If one go past the
Wait, one go past, then you have three collinear points, right?
Yeah.
And that's weird. Oh no, maybe not.
So.
Can you prove that it doesn't go collinear? But like, if the one of them doesn't go collinear, the second one will.
That's a good point. Okay, so let me keep reading, okay? So as to obtain an oblique pedal triangle.
What?
A1, B1, C1.
Oblique.
What does
Yeah.
that mean?
What does that mean? It just means it's not perpendicular anymore.
Okay,
Just what?
What is this laughing?
Okay, clearly the circles A, B1, C1, yeah? So A1, B, C1, and A1, B1, C continue to pass through P, yeah? So the circles continue to pass through P, yeah?
Yeah, but they're not my.
Okay.
That might not be the.
Wait,
As soon as I leave my area, that doesn't mean
wait.
it's through
So
my.
if you rotate, then like.
Yeah, so it is not necessary for A1, B1, C1 to form a triangle. They may be collinear.
What? And then which
How?
points are you doing?
How can
What?
they be?
And then which way? Then in that case, which?
How can they be collinear when like?
Oh, but they can though. Which?
So like put B1 on
And it
A.
would just be
B1 equals A.
Oh, okay. You can do that. I thought you can't put B1.
B1
on
equals
A.
yeah, but then like
If like C1 equals B, then as long
well, are they
as
claiming like A B1 P C1 is still cycling?
Alright.
It's not
So
supposed
if
to
we-
be cyclic, even
So
if
put it
goes
here,
past.
right? We have like gamma here, yeah?
Gamma.
Wait.
Why is gamma so
And then
small
this
now?
is like beta. Oh,
Yeah.
wait, I'm confused. Beta goes.
So it doesn't matter.
Why is
let's
gamma
say
so
here,
small
yeah.
now?
no, it still works out because they add up to
What?
What?
How
does this work now?
But like, how are you gonna have 3 points cycling?
You can't have your 3 points are always cyclic. So you're saying there's a
No,
5
no,
point cyclic?
How do you have 3 collinear points cyclic?
What do you think?
Because 2 of the points are on the line now, right?
Yeah, so they're not cyclic.
You just draw an ice cream.
What?
Like collinear points are definitely not cyclic.
Yeah. So what is it like saying?
Okay, so as in figure 2.5, right? Yeah, hold on.
Oh, we're going
What are we
backwards.
doing now? Oh, 2.5 equals.
好，我就马上好。对。Oh. So it's like the Simpson line thing.
Oh my. Oh.
Because the pedal triangle on the outside, right? If it's
Yeah.
collinear, then it has to lie on the circumcircle, remember? So I guess it's not talking about this case where it's rotating, I guess. I think if it rotates, could you show that it can't ever go collinear? Because this angle alpha gets pretty huge.
No, okay. Well, one of the angles has to go collinear. Like,
Why is
there
it
has
trying
to be a
poke you as
point.
well?
Like,
Is
there
this
has to
the
be
side about when like
I'm just very
It's on
pokey.
these circumstances. It's not for
no, like are they talking about when
The Simpson line.
I don't know what to say.
I mean, John Friedman.
I forgot about the Simpson line already. Simpson line.
Alright, so how about, we'll continue this after dinner and we'll do some problems on this, yeah?
Oh yeah.
Pardon.
And then we can skip similar switch for Friday. Because apparently you know it.
Yeah.
Yeah? And then that should have covered everything.
It's not for Friday.
Oh, can we do like
I do.